Okay, so in this video I'm going to have a look at differentiation using the chain rule, and I'm just going to have a quick look at this function here first of all, which is y is equal to f of x, which is equal to the square root of 3x squared plus 2. Now this is a composite function here, and we can break it up into, we can call u 3x squared plus 2, and we'll call it h of x. So instead of 3x squared plus 2 here, we can just simply put in u here, and we can call then f of u then would just be the square root of u. Now f of x, then this function here is just simply a combination of these two functions. In other words, it's f of h of x. So the h of x is 3x squared plus 2, that's this bit in here, and then when you put it into f, you just get the square root of it. So you end up with the square root of 3x squared plus 2. Now if we differentiate this, we just simply end up with the differential of, we differentiate u, or f of u rather, and multiply it by what we get when we differentiate h of x, this here. So all we're really doing here is differentiating this. So you get 6x plus 0, if you like, or just 6x, and then differentiating the square root part here, this part here as well, just in terms of u, multiplying the two answers, and you get your differential of this function here. So what it breaks down to is dy dx here is dy du times du dx. So this is your basic rule here. Now let's have a look at an example of how this actually works, you know, in practice. The theory can be a little bit tricky, but let's have a look at an example. So say we take, let's say we take, I'll just change the color here. So let's take f of x, and we'll take it as being, let's see, the square root here of x squared plus 4. And we'll actually say the cubed root here. We'll use the cubed root here. So again, this is a composite function similar to what we've just done there earlier. So let's look at using the chain rule to differentiate this function. Now we can use this here, and there is an easier way of doing this, or an easier way of looking at it, which we'll look at later on, but we'll use this rule here first of all. Now this is just y here, if you like. So we want f dash x. So first of all, I'm going to let this y here, I'm going to let y equal to u cubed root of u. Okay, so instead of this x squared plus 4 here, instead of this x squared plus 4 here, I'm going to call that u, so x squared plus 4. So a combination of these two will give us our function here. We have y is equal to the cubed root of u, where u is just the x squared plus 4. Now this cubed root of u here can be written as u to the power of a third. Okay, so let's use our chain rule then. So we want dy du and du dx. So let's have a look at that. We look at dy du first of all. Let's do it in green here. So this is our y function here. So y is equal to u to the power of 1/3. That means then that the y with respect to u, du, is going to be, bring the third down, so it's 1/3 u to the power of minus, when you subtract, you have to subtract 1 from 1/3, so that gives you minus 2/3 here. So that's our dy du. Okay, so now let's look at the other one we need here is du dx, so let's do that one. So du dx, I'll do that in, let's say, this color here. So we have u is equal to x squared plus 4. And what we want here is du dx, du dx. So du with respect to x. So we bring the 2 down here, we get 2x, and this will become 0 here. So du dx is 2x. Now let's go back to our original problem. Here we have y is equal to f of x, which is equal to the cubed root of x squared plus 4. And what we're looking for is f dash x, or dy dx, whichever you like. So from our rule up here, we need to take dy du. So we're going to take dy du, which is this part here, and that's going to be 1/3 u to the power of minus 2/3, and then we've got to multiply that by du dx. Du dx here is just simply 2x, so we're going to multiply by 2x here. So this really is the answer. Now you'd probably be expected to just resubstitute back in the u and then simplify it as much as possible. So let's have a look at that. Okay, so I'll just get rid of this dy dx here first of all, and let's just substitute back in the u here. Now, so we have 1/3. Our u here, remember, was x squared plus 4, this bit here. That's to the power of minus 2/3, and we want to multiply all of this by 2x. So let's see what we can do with this. Well, the 2x here we can bring over here, so that's just simply 2/3x. This bit here is just going to become 1/x squared plus 4 to the power of plus 2/3, using the laws of indices. This is this to the power of minus 2/3, so that's just 1/x squared plus 4 to the power of plus 2/3. Now let's just do a little bit more with this. We have 2/3x here, and we have 1/. Now this here can be simplified as well into the square root. Well, it's actually going to be the cubed root, because we have a 3 here. Our denominator is a 3 here. It's going to be the cubed root of our x squared plus 4. And you know, there's a couple of ways you can do this, but we'll just stick a bracket in here. All of this to the power of 2. So that's really it. I mean, that's as basic as you're going to get it, really. 2x/3, x squared plus 4 to the power of minus 2/3. Really, you could leave it like this, or you can mess around with it depending on what way you want to actually write it. So let's have a look at another one then. Just move this up again. So let's go back to white again. Let's have a look at y. In this case, y is equal to x cubed minus 25, x cubed minus 25, and this is to the power of 2. So we want dy dx, okay, dy dx. So we're going to let u, so let's see, we'll just let u here equal to x cubed minus 25. U is equal to x cubed minus 25. That's just simply what's in the bracket there, inside the bracket. And then we're going to say y then is just going to be u squared. So this y here is just the u squared. Okay, so we need two things then. Well, I'll write we'll write down the formula first. Dy dx is equal to, remember, if we go back up here again, our rule was dy dx is dy du times du dx. Dy du times du dx. Now if you look at that, if you imagine you have two fractions here, this du can divide into this du here, and you're just simply left with dy dx equal to dy dx. So anyway, let's do this out. We have we first of all have u here, and we need, well, we'll do the y first since we have y first here. Dy du, so we want to do dy du first of all. So we want to differentiate y with respect to u, so differentiate this bit here and you get 2u. Now we're going to differentiate u with respect to x, so that's du dx, that's this part here, du over dx. So that's going to be 3x squared. Bring the 3 down, you have your x, subtract 1 from 3 and you get 2. So now we have dy du and du dx. So let's just do this here then. We want dy dx, and that's just simply going to be dy du, which is 2u, multiplied by 3x squared. 3x squared. Now you would be expected to substitute in then what u was. Well, we know u was x cubed minus 25, so put that in there, multiplied by 3x squared. Now really that's it, that's your answer, but let's see if we can tidy it up. We can multiply this 3 by this 2 to give us 6. We have the x squared there, and then we've got the x cubed minus 25. And that's it really. I mean, you could multiply out the brackets there if you wanted to, again, depending on what way you want to want your answer. Now let's have a look at this one again. I've done 2 examples using this rule here, but let's have a look at this particular one and see if there's an easier way of doing it, or an easier way of approaching it. So we have, let's see, y is equal to, so we started with y is equal to, what was it again, x cubed minus 25. So it's x cubed minus 25 all squared. Now we want to differentiate that. So we want dy dx. So an easy way to look at this would be, what we are effectively doing is just taking this as u squared and we're differentiating it. So what we're doing then, if you differentiate u squared, you get 2u. So in other words, take this 2 here, bring it down here. Do nothing with the bracket because it's u if you like, so it's x cubed minus 25. Subtract 1 from 2 and you get 1. We are then multiplying that by what we get when we differentiate what's inside the bracket. So differentiate what's inside the bracket here and you get 3x squared, and the minus 25 will just become 0, and that's it. So again, just multiply the 3 by the 2, you get 6x squared. And here you've got x cubed minus 25. So that's a quicker way of doing it. Just take the 2, bring it down here, leave the bracket alone, reduce by 1 here, and then differentiate what's inside the bracket. And you can see here we get the same answer there. Okay, just one more of these and we'll do it the quick way. So let's take y is equal to, let's say 4 minus x squared. 4 minus x squared, and we'll raise that to the power of, let's say, minus 3. Okay, so we want dy dx here. So again, the quick way then, I'm going to take this minus 3 here, and I'm just going to bring it down here again like I would normally. So it's minus 3 times, do nothing with what's in the bracket. Remember, that's your u at this stage, so it's x squared. Reduce the power by 1, so that becomes minus 4. Multiply all this by what you get when you differentiate what's inside the bracket. So if we differentiate only what's inside the bracket, we get 4 will disappear, bring the 2 down this time, bring the 2 down here, and you get minus 2x, and then reduce the 2 by 1, which just becomes 1 here. So that's it. Let's see, can we do anything with this? Well, I can multiply that minus 3 by the minus 2x, so that will give me 6x. And here I end up with 4 minus x squared to the power of minus 4. And again, you can leave it like that, or you can write it as 6x over 4 minus x squared to the power of plus 4, whichever way you like. And that's it for the chain rule.